Yeah, thanks. It's good to be able to talk about IFC, one of my passions in life, I think. But we've got, the bylaw is a joint venture between Lango Rock and Bouygues, and we're only responsible for the main civils works. So it's not like a normal project where we'd cover the whole lot. Our scope is just the civil engineering, just building a lot of very large concrete and steel structures. It's going to be one of the I think it's the biggest project in Europe at the minute. I think everybody's probably aware of the scale of it, but just to give you some idea, those domes are like 60 metres across. That's a 14-storey office block in the middle. The front buildings start about 45 metres underground, and there's about 7 kilometres of underground tunnels connecting it all together. So it's epic construction. A lot of challenges. I've started when we use the IFC. We've kind of got two sort of goals. Well, a goal and a vision, and the goal for us is to be able to build on time and on budget. So certainty is very, very important for us. So we're very, very keen on knowing how the construction goes together. So we put a lot of effort into that when we're working with the designers. So all the models we receive, at the time we get to construction anyway, we've gone all in sort of level 5 of detail of the models that you receive. So every bar, weld, plate, absolutely everything is modelled, even the temporary works aspects. And we do working with the designers in collaboration. And again, collaboration is quite important. It is an interesting project in that we do not employ the designer, and we don't even have the same direct client as the designer. So all the design collaboration is purely collaboration. There's no sticks involved. And as you can see, we literally see for the rebar. Obviously, we do a lot of rebar, but we are literally building everything once in the virtual environment. And then when we get to site, we also use these kind of animations for the steel fixers as well. So it's like a how to build before you get going, visual method statements. And as well for us, what's really important as a civils contractor, everybody's used to design coordination, class checking, sequencing. But that's kind of the finished static state. But for us, there's many different versions of the finished state as we're building. So you can see there, we go to this full effort of modelling all the temporary works exactly how it should be. So that's it. So yeah, the first step is the geometry, and from our perspective, to be successful, sort of drawing the line at if it's going in the permanent works or temporary works, it has to be modelled. As to be built models. The much more difficult part, and where IFC plays a really strong, is all this stuff on the right hand side. People think, oh, we're a construction company and we just build stuff from drawings or models, but it's actually much more complex than that. We fabricate things. We do forecast method statements. We have. We pay people wages, we have plant logistics management. So we're actually quite a large company other than just construction. And for any of this to sort of work, I think we've got something like 80 different softwares and databases within bylaw. And all this data needs to be able to be transferred between these two systems. So it's very, very critical. That's why on the left-hand side, the design, the models, or the IFC models, we've specified everything IFC on the project, so they're the only models we receive. But if that data in those models isn't correct, then none of that on the right will ever come together in any ordered fashion. So the first thing we do to make it work, and this is sort of above the model really, but applied to the model, is agreeing for any big project or any small project, is agreeing a classification system. And it sounds really, really obvious, but it doesn't happen on most jobs. You have the architect will refer to things as column 1, the engineer will refer to it as column A, he'll refer to it as level 1, he'll refer to it as floor 1. And when you move to a database workflow, all that stuff becomes really, really important because you have to have unique keys to link things together. So the first specification to make things work is a classification system. And it's not just for models, it's for your planners, your procurement people, your cost controllers. Everybody has to have the same work breakdown structure. And how it does relate to models is that classification on every single IFC modelled object that we receive has to have all the classification on it. So as well as material data, all objects have to have full classification data as well. And then this is the material data. So what we've done, we've been quite selfish from a civil contractor's perspective, but we've basically wrote a specification for model deliverables that says, like for rebar models, we've wrote like a specification for all the data that needs to be on there, so we can fabricate direct from that. When we buy plates from Payco, we've established a agreed data structure to be on all plates, which is kind of it's a similar idea to what like the MBS is doing, where we go to a material type and you can specify it, and it says for level 5 put this information in. Well, we've just sort of took it to another sort of level of standardization, and we've put our own personal requirements in there, so you can do what you need to do with the model. And then because you've got specifications, you can actually check your models. If you don't have a specification, you can't. There's a lot of model checking going on now, but it's kind of sort of just looking at it and clashing it. But if you have a data spec, you can write very, very detailed rules to check that data is correct, so that the rest of your team can use it. And this has come up. I think everybody's kind of used to seeing a model in a bubble in the middle with lots of stuff going on around it and saying data going backwards and forwards to the model. But what we're actually finding is, is the model the database, or is there another database that the model links to? What we're finding is we've got quite a lot of databases. We're building a lot of SQL databases now on central servers that the other softwares talk to. But the initial database structure, we're deriving directly out of the IFC. So as the IFC evolves, we export the next level of classification data, and that updates the database. And then you just start adding more and more stuff to that database. So we looked at, there's something on quantification in the previous presentation. And if you have classification data and quantity data in your model, quantity takeoff just happens like automatically. If you think pivot tables, Excel, sort by classification, building level zone, material. And that sort of forms as a construction company, everything that we do is based around that breakdown of that breakdown structure. And then we just go through and add more data to it. So you've got location data, you've got material data, that's in the original database set. You then link the program. Oh, that's supposed to be a video. You then link the program. I don't know if I can press it. No, that's a 4D sequence anyway of the construction going together. But we link in then Primavera as a database, so we link the date data. You can see that sort of attends onto your database, and then you can do forecasting data by zone, by element, by building. The rebar, this has been a very long project to get this working, and we hope that we can sort of share this learning back into the industry, because it has took a long time, but we are now fabricating all reinforcement directly from IFCs, which is it's been a lot of effort, but it is working now. But you can see how many databases need to link together. You've got the model itself, Primavera for dates, the IFC that creates the data, fabrication management systems, and then even third-party fabrication management systems, which is ARM+. But yeah, it's basically fabricating from third-party IFC data direct from a designer. So that's been a real success. Again, databases generated direct from the model, creates all the digital forms, and you can, because you've got a good classification system and materials, so every port, that's pores for example, every port on a building has a unique ID. So instead of having to go onto site and create a form and say, I'm doing a form for this task or this task, all the forms are already pre-created, like direct out of the model database. So you can just go through and fill them in, and obviously that's then tied back into another central database. And then this is where we are now. We're starting to think about data-driven delivery and actually understand what's going on the project, because while they're in paper-based systems, it's very, very difficult to understand what's going on. But now we haven't quite achieved yet the super mega awesome database of everything, but we're working towards it. So we're building more and more databases and starting to link databases together. And for things like productivity tracking, it's and forecasting as well of materials and assessing how well the project's doing through dashboards. It's I don't know. It's fantastic. We don't normally do it. And then this at the bottom, I suppose, just because the models created the database in the first place, you can also do model-based visualizations because the data hook in the database is linked back directly from the model. I've got to hurry up, I think. So,
there might be questions. But,
and then. So I wanted to show you this. So everything that's been shown so far up to there, nobody has used any drawings at all. None of our teams use drawings now before you get to the construction site. Everybody sits and looks at the model. Planners use the model. Engineers use the model. Everybody just uses the model. Nobody, drawings are a hassle up until the point of when you reach the building site itself. Because at the minute, inquiring data from the model's fine if you're in an office environment and you've got a mouse and a keyboard. But then once you move on to site, using standard applications for iPads and Androids, it's quite difficult because when you look at it, like things like plates. If you've just got a data model, you have to pick on the plate and ask it what it is. But when you're building something, you want to be able to look at several things together and see all the information you want to see, which is basically why we have drawings in the first place. So we've wrote another specification. Everything comes down to specifications. People moan that the models weren't good enough or whatever, or the designer's not doing a good enough job. But it's basically the client or the contractor's fault because we didn't give them a good enough specification. But we've wrote that now, and the designers have delivered the first, what we call, just annotated models. But what we've done is the annotation is also IFC, so it's 3D IFC objects for text, and we've put the same classification and coding data onto the 3D IFC text. So then when you're in your model, when you filter for floor 1, it'll just show you floor 1 and all the text for floor 1. So we're moving into interactive drawings on an iPad through the model. We've built, last month, we built the first section drawing free on site, just using IFC annotated models. And then this is literally, I got this email like last night. This is the pinnacle of where we are at the minute for drawing free. So even reinforcement, and it's the complexest reinforcement, that there is. It's nuclear reinforcement, but we're now building the first sections without any drawings, just using iPads as interactive models, and this is the most exciting stuff for us because drawings are really starting to be just become an inconvenience. Nobody wants to go through 100 drawings. They want to be able to be using models and data. So you can see that's the sort of classification. So if you imagine now on an iPad, you're creating an on-the-fly drawing. So you'd say, I want building 1, level 1, cage 1. just the anchors in the bottom, and then it auto then filters using the data on the text and the bars to give you an on-the-fly drawing. Yeah, so hopefully by 2019 we'll be building Hinckley without any drawings, which is one of the main ambitions. And yeah, I don't know. I like that. I think that's exciting. So if there's any questions.
So you in design are able to not use drawings. What about your client in doing design review of the partial submittals? Are they also not using any paper?
Yeah, so we at the minute we still have the drawings. These trials that are ongoing now for particular bits, we haven't made the final decision not to use drawings, but it will be coming. But what we're doing is on all these trials, the client, the designer, and everybody's involved, and we have like regular meetings and training for people, and we share we've developed quite robust model design checking procedures, and we share all that with the client and give them the relevant training, so they're training up their people to use the models instead of drawings as well. The feedback to all was very positive. I mean, this job you're talking like hundreds of thousands of drawings, and finding what you want is very, very difficult. We had like the gallery sections. There's 7 kilometres of galleries, and just as an example, one of the annotated models replaces like 95 drawings. So you can imagine from a document management perspective, which is preferable.
Can I ask another question related to that? And so
There's apparently, this is a nuclear facility, there must be some high security. Some of the owners I work with are concerned about exchanging information over networks that may or may not be secure when it has a high level of security, and a lot of the review tools are cloud-based, so are you working around those issues?
Yeah, we do have to work around that. We're a bit lucky on the civil side because we're not fully classified, because we're not involved in the M&E and the plant systems, which is a higher classification. So the civil is quite low on the classification, but there are rules. We're not allowed to. We've ended up like building an internal server system basically, and then we've developed all the mobile applications to work offline. So it's more when like these are sort of created into package files that are then put somewhere. So we are avoiding the cloud.
question here.
So,
Just leave it till 10.
okay, brilliant. For a while, some of us have been talking about BIM eventually being the death of drawings. It's nice to see you guys taking that step.
Yeah.
I guess, but related to that is, I'm assuming then you have a system, you have procedures when it comes to this idea of provenance of the model for, progress. Like, this is the latest model, don't refer to the old one. Or it gets removed somehow, and everybody's aware of
Yep.
that published version of the model versus something that's in progress.
Yes. So, because I don't know, I think it's the difference for us is from a logistical point of view, it's no different to a drawing. How do you know you've got the latest drawing? It's because you have a good process in place that ensures that people through a document management system have access to the latest information. But what we've done on the models, for example, every single modelled object as well. So in our design, in our model specification, there's a separate properties tab for status and revision. So every single object within the model has that status. And one of the things we've done as well is there's kind of a bit of an obsession with like the full model, and the architect issues the full model, and everybody looks at it every 2 weeks and goes, oh yeah, looks all right. We've kind of broke it down into like from a construction, like the issue was the ground floor, and especially on design and build projects, it's a roll in progress. So let's issue the ground floor. Everybody will sign off the ground floor, status it for construction. Never issue it again unless it changes, and then you know, changing the design releases into separate models has been a part of that as well.
Thanks. Yeah, very impressive stuff. What's been the reaction from the site workers, really having to work with the iPads and working with the data on site? Was there initially kind of a resistance, or were they taken to it straight away?
It's, if you tried to take them off them now, they'd hit you with it. I think, yeah, you know, I think the difference is, like, everybody's got an iPad or a smartphone, so nobody's scared of them because everybody uses them day in, day out. You know, some of the guys, if you put a computer in front of them, it's a different thing because they're not used to using that kind of operating system, but Android, iOS systems are set up in a way, and yeah, so the delivery, I mean, the jury's still out whether we've done the concrete trials, and it looks very positive that there's a good chance we'll pull like concrete formwork and set out drawings, because it just is a better solution. The rebar, like, as you know, it's jury's still out on that one. They are quite, but they're complex drawings as well, so it's never going to get easy. It's just can one replace the other, I guess.
Okay, well, all right.
One last one.
Are you guys using laser scanning to verify what you build? Do you merge those point clouds with?
Yeah, we've used it. We're not responsible for the earthworks at this stage. So we have on this particular. We use it on other projects for the Hinckley project. We haven't used it yet. What we've trialed it for on Hinckley is like the rebar is very, very heavy. And there's a lot of couplers, and it's all 40 mil, so it's like, you know, bending a brick. You can't. So we're going to, if there's some quite detailed prefabricated elements. So we've looked at once you've cast in the bars that are in, if you scan that, then you get kind of an as-built, and then in the prefab yard, if you scan the next prefab cage, you can kind of do a virtual check, which for us, like crane time is obviously a very big problem for us, time on the hook. So if we can guarantee that it's going to fit together before we can, then yeah. So that's the plan.
So I have a question for you before you go. So we've set up a working group within the standards programme, which is being supported by you and your colleague Terry, who was here earlier in the week, and several other companies. What do you hope for from buildingSMART from that working group?
I'd hope that we can transfer. I mean, because there has been a lot of lessons learned. I mean, generating a bending schedule from an IFC is quite straightforward, but it gets, once you get into then actually fabricating from that and all the necessary rules and data structures required to go into the existing UK systems and things. But we've wrote a standard. Obviously, it's a selfish standard, but but the UK industry is pretty standardised for rebar. So I would hope that working with other people, because you know we might have missed some things as well, that we would be able to, instead of giving them the bylaw specification for rebar model deliverables, we don't want to have to write specifications ideally. I want to be able to say, deliver me a model compliant with IFC rebar spec 203 or whatever it is. So that's what we hope to get out of the working group.
Okay. Thank you, Paul. Your enthusiasm is infectious, because we spent some time with you in the office a few months ago, and we could probably listen to him all day. And that's a really great practical example of open BIM. So thank you very much.